Once again, welcome back to our channel. In this video, we are going to discuss the revision questions, that is MCQ questions from first lesson, real numbers. Let us move to the first question. The number 4 raised to n, where n is a natural number, ends with the digit 0 for any natural number n. Okay, that means we have given a statement, that is 4 raised to n is ending with the digit 0. Okay, we have to select the correct option, true, false, can't say, partially true or false. Yes, children, if a number ending with the digit 0, you can take any number, that is for example 10 or 20 or 30, whatever it is. You do the prime factorization. You can say that easily, in the prime factorization of the number contains the prime factors 2 and 5 both. 2 and 5 should be there. Then only all such numbers ending with the digit 0. See children, 10 can be written as 2 into 5. 2 and 5 are the primes. 20, that is 4 into 5, that is 2 square into 5. 33 into 10, 2 into 5, right? All these numbers you can see both the prime factors 2 and 5, then only those numbers ending with the digit 0. So in this case, you have to check whether the numbers is of the form, that is 4 raised to n means 4 raised to 1 or 4 square, 4 cube, where n, the power of 4 can be any natural number. Okay, will contain the prime factors both to 2 and 5. If it is so, you can say that this is a true statement, otherwise false. Okay, so 4 raised to n, in the prime factorization, 4 is 2 into 2. 2 into 2, that is 2 square, and 4 raised to n means 2 square whole raised to n or 2 raised to 2n. Understood? See, in 4 that is 2 square. So in 4 square is, you know, 2 square, n in place of n you can substitute 2, that is 2 raised to 4. You can see only the prime factor 2. The prime factor 5 is not there, which means that any number is of the form 4 raised to n never end with the digit 0, because in the prime factorization of 4 raised to n, the prime factor 5 is not there. Or in other words, a number which is ending with the digit 0 must be divisible by both 2 and 5. Then only you can say that the number is of the form 4 raised to n is ending with the digit 0. But here in 4 raised to n, the prime factor 5 is not there. Understood? See children, 4 square, that is 16, prime factor 5 is not there. Okay, and 4 cube, okay, 64, 5 is not there. Okay, so this is a false statement. Now the second question. 12 raised to n ends with the digit 0 or 5 for natural number n. Which natural number n, this 12 raised to n end with the digit 0. That is, n can taken 2 or 3 or no value or 5. Okay, so for this question also, do the prime factor. This is why, because we are taking the help of the fundamental theorem of arithmetic. That is, the prime factorization of every composite number is unique. Okay, that means in the prime factorization of 12, you can see that 4 into 3, that is 4 is 2 square into 3. Okay, so 12 raised to n means 2 square into 3 whole raised to n. So you can distribute this n for both the factors 2 raised to 2n into 3 raised to n. That means the only primes are 2 and 5. Here also the prime factor 5 is not there. So n will take no value. Okay, for n equal to 2 or n equal to 3 or n equal to 5, whatever the value for n, you can see that 12 raised to n is never end with the digit 0. Why? Because in the prime factorization of 12, the prime factor 5 is not there. Understood? So here the option C is the correct answer. Understood? Now the third question, the value of x in the factor tree is, It's a very simple question. We have given a factor tree and we have to find out the topmost number is marked as x. X comes in the root number, that first number, okay, and that is these branches are the factors, okay, factors of this x. So in order to get the value of x, see, we can start from the bottom level, okay, that is 2 into 3, that this column is the product of 2 3s are 6, understood, and 5 6s are 30, right? Okay, and the product of 5 into 30, that is 150, 5 3s are 15 and 0. So x is equal to 150. Understood? So we can start from at the bottom level and take their product from where this branch started. So that its column is the product of these two numbers. Okay, so 6, and this is starting from this box. So its product is this column. Okay, and this x these two boxes starting from this root number, that first number. So this will be, the product will be the value of x. So these options, it is given B, that is 150 is given. Okay, now the next fourth question, root 2 minus root 3 into root 3 plus root 2 is, we have given 4 options, is a natural, is a rational number, is a whole number, an irrational number and a natural number. Okay, among these 4 options, which will be the correct one? We have given, this is the expression, that is root 2 minus root 3 into root 3 plus root 2. So see children, you can see root 3 and root 2 in both factors. Okay, and in order to apply this identity, being a and you can see both are there here. So in order to apply the identity root 2 minus root 3, we can't make any change because they are connected by minus sign, subtraction. Subtraction is not commutative, and but here they are, since they are connected by plus sign, you can change their position. Okay, that is root 2 plus root 3, a plus b equal to b plus a, commutative. Okay, so now this become a plus b into a minus b, and what is that? A square, that is in place of a, the first position is a, that is root 2 whole square, that is 2, and b square, root 3 whole square, that is 3 itself. Okay, and that is equal to minus 1. And minus 1 is not a natural number, it is not a whole number, it is not an irrational number. Minus 1 comes in the negative left side of 0. It is an integer. All integers are rational number. All integers are rational number. Okay, so here the first option is the correct option. Okay, minus 1 is not a natural number, it is not a whole number, it is not an irrational number, but it is an irrational number. Why? Because it is an integer. Negative 1 is an integer. All integers are rational numbers. Okay. Now the fifth question. The least prime factor of A is 3 and least prime factor of B is 7. Then the least prime factor of A plus B. Here A and B are a number, a natural number. Okay, and it is given that in that natural number, its prime factorization, 3 is the least prime number. Understood? So can we take A as 6? If we are taking A as 6, you can write 2 into 3. Can you say that 3 is the least prime number? No, so we can't take 6. Okay, you can take the number whose prime factorization and in its least prime factor must be 3. Okay, so if you want, you can take 3 itself. Okay, so let A be 3 and B equal to, in the second number, the least prime factor is 7. So you can take 7 itself. Okay, so what is asked? Okay, what is asked? The least prime factor of A plus B. If A equal to 3 and B is equal to 7, then A plus B will be 3 plus 7, that is 10. And what is the prime factorization of 10? 2 into 5. And which is the least prime number? 2. And you can see that 2 is the first option. Understood, children? That means if in such problems, okay, you will get A and B are always an odd number. The sum of two odd numbers will be always an even number, and in the even number 2 is divisible, and we know that 2 is the least even prime number. Okay, so in a plus b, you can see the least prime number will be 2. Understood? And the sixth problem. If a and b are co-prime, then a square into b square are. What is given, children? A and b are co-prime. What are co-prime numbers? Co-prime numbers are any numbers. It need not be prime number. You can take any number. The only condition is the highest common factor must be 1. That means there should not be any common factor between a and b. So we know that all consecutive numbers are co-prime numbers. You can take any consecutive numbers, for example 3 and 4, 5 and 6, whatever it is. So we can take a as 3 and b as 4, because in 3 and in the prime factorization of 3 you can see that 3 into 1. Here you can see that 2 into 2. Can you see any common factor? No, other than 1. This here you can add, and 1 is a universal factor. Okay, so the only common factor is 1. So such numbers are said to be co-prime numbers. And what is asked? In a square into b square. A square into b square will be what type of numbers? Whether it is co-prime numbers, not co-prime numbers, odd numbers, okay, and even numbers. Let us see. So if a is equal to 3, a square will be 9. Okay, and b square will be, if it is 4b, 4 square is 16. Can you see any common factor in the prime factorization of 6 and 9, 16? That is 16 and 9. So 3 into 3, here 2 into 2 into 2. No common factor. So a square into b square is also co-prime numbers. That means between 16 and 9, we can't see any common factor other than 1, or the HCF is all the co-prime numbers, HCF is 1. Okay, that means common factor is, highest common factor is 1. That means here a square into b square is also a co-prime number. So the definition of co-prime number is clear, children. Any numbers, it need not be prime numbers. Understood? Any prime numbers, okay, whose HCF is 1, or they should not have any common factor other than 1. Okay, such numbers are said to be co-prime numbers. For example, all consecutive numbers are, what is it? Co-prime numbers. And we also know twin prime numbers. For twin prime numbers, the selected numbers must be prime numbers whose difference is 2. There two conditions should be satisfied. The numbers must be prime numbers and their difference must be 2, that is 3 and 5, 5 and 7. Understood? 17 and 19. The numbers must be prime and their difference is 2. Such numbers are said to be twin prime numbers. But here what is asked? Co-prime numbers. Okay, so any number you can take, but the only condition is HCF must be 1. No other common factor other than 1. So a square into b square is also a co-prime number. Okay. Now the seventh question. The largest number which divides 615 and 963, leaving remainder 6 in each case. In such type of question, children, the largest number which divides 615 and 963, whatever the number, if the problem is of largest number and you should get the remainder, okay, in such cases you have to get the HCF. HCF is highest common factor. So largest and highest, same meaning, okay. And here provided 6 will be the remainder. That means you have to take, you should not take directly the HCF of the given numbers in the question. Okay, the remainder must be 6 in each case. That means the required number will be the HCF of 615 minus 6. Okay, then only when you divide, you will be getting a number remainder 6. Okay, and that numbers HCF of this, and the same way 963 minus 6. Understood? Okay, and that will be, when you subtract this 6 from 615, what will be the number? 609, and 963 minus 6. Okay, you will be getting 957. Okay, and the HCF of these two numbers will give you that largest number. Okay, and when you divide that number with 699 and 953, you will get a remainder in both cases 6. That is the meaning. That means you have to find out the HCF of the numbers which you are subtracting subtracting 6 from the given numbers. Understood? Okay. So 690, prime factorization, you will be getting this, you can start with the 3. Okay. So 203. Okay. Now you can divide with which number, children? 7. Okay. 7 in 20, 2 times 40. So 63, 9 times. 29 is a prime number. Okay. That means 3 into 7 into 29. We are going to get the HCF by prime factorization method. Okay, and 957. Okay, you can start with 3. So 3 in 9 3 times, and in 5 1 time, remainder 2 and 19. And which number, children? Can you divide with 3? No. 7. 7, if we are taking 7. Yes, you can start with the 7, that is 28. 28, that is 4 times 23. Okay, so we can take 7. 39, I think 49. Okay, so what about 11? Yes, 11. 11 in 31, 22, 2 times, right? 22, 22 after 22, 31, 9. 9 9s are 99. So 9 into 11 is 99. So 29 is also a prime number. So that means 957 is equal to 3 into 11 into 29. We can stop because 29 is a prime number. Okay, so here how can we get to the HCF by prime factorization method? Find the product of least power of each common factor. Yes, 3 is here, here also 3, and both having the power 3. Okay, so HCF equal to 3 into, next 7 is not here, 11 is not here, so we can't take both 7 and 11. Okay, and 29 is here, here also 29. So the product of 3 into 29, that means 3 9s are 27, 2 carries 2 3s are 6 plus 2, 87. Can you see it? Yes, 87, that is C is the correct option. Okay, when you divide 609 with 87, you can see that there should not be any remainder, exactly divisible. But when you divide the 615 with the 87, that case you can see that the remainder is 6. The same way 963, when you divide with the 87, you will get the remainder that is 6. Okay, so this is the way, children, that number will be the HCF of the number, okay, by subtracting the given remainders from the numbers. Understood? Now the next problem is another important question. 4 bells toll at intervals of 10 seconds, 15 seconds, 20 seconds, 30 seconds respectively. They will toll together at 10 a.m. 10 o'clock in the morning. Okay. At what time will they toll together for the first time after 10 a.m.? Okay. After 10 a.m. Okay. At what time they will toll together? Okay. That means, children, here the expected time is definitely more than that 10. That means in such cases you have to find out the LCM of these 4 numbers. When after reading the question, if you see that what is a number which is common in that way, children, that case that number is always less than the given numbers. Okay, so there you have to take the HCF. HCF is always less than or equal to the given numbers. Okay, LCM is always greater than. Okay, so there should be a confusion sometimes some children may have. Okay, this is idea, children. After reading the question, the concept is it will be a greater number than the given numbers. In such cases, you have to find out the LCM. here that comes greater than, okay, that number will be more than that 10 o'clock it is over, okay, and the next time, okay, so there you have to find out the LCM, okay, so LCM of 10, 15, 20 and 30, okay, that means here 10 equal to 2 into 5, okay, 15, 3 into 5, 20, 4 into 2 into 2 into 5, 30, that is 3 into 10, so 2 into 5. So LCM of 10, 15, 20 and 30 by prime factorization method. You have to find out the product of each prime number occur in the prime factorization. Okay, here we are not considering the common. Okay, so 2, 2, 2. Okay, 2 is not here is there, so you have to consider 2 and the greatest power is 2 itself. Okay, so you have to consider 2 for taking the LCM, and 5 here 5 also is a common factor, but power is 1, so 5. Okay, and here 3 comes as a prime factor, so you have to consider 3. Yes. Okay, so all the prime factors we have taken here. 2 children, 1, 2. Okay, here the power is 2 square. Okay, so you have to take the power, greatest power of each prime factor occurring in the prime factorization. That is the definition of LCM. Okay, here 4, understood, so 2 square into, so 2 square. Okay, so here you will get 60. 2 square, that is 4 into 5. 20 into 3, 60 seconds. All are in seconds. Okay. So, after 1 minute, okay, after 1 minute, they will toll together. That means 10 o'clock was the last time, that time at which they toll together. The next time will be, you have to add 1 with 10 a.m. That means 10 hours, 1 minute. You see that options here. 10 there, here this comes the correct option, that is 10 hours 1 minute. Here is 10 hours 2 minutes. That is wrong because we got the 60 seconds is 1 minute. Here 10 a.m. 30 seconds. Okay, here 45 seconds. 10 a.m. 10 hours 45 seconds. So the correct option is the first option, after 1 minute. That means you have to add 1 minute along with the last time at which they toll together. That is 10 a.m. plus 1 minute is 10 hours 1 minute a.m. Now the 9th question. 3.27 bar is an integer, a rational number, an irrational number, none of these. This is a question from 9th standard topic. Okay, can we write this 3.27 as, we learned that the digits which comes under the bar is repeating. Okay, that means this is equal to 3.27, only the digits comes under bar is repeating, 27 etc. That means this decimal expansion never stops. It will not terminate, but non-terminating, repeating. The block 27 is repeating. So whose decimal expansion will have non-terminating repeating decimal expansion? For a rational number. Okay, so the rational number has two type of decimal expansion. Either it terminates, that means remainder will be 0. The second choice is non-terminating, repeating. So this 3.27 bar is a rational number, second option. Now the last question. If 13 by 125 is a rational number, then the decimal expansion of it, which terminates, because we know that the decimal expansion of a rational number will terminate when the denominator, the prime factorization of the denominator have only either 2 or 5 or both as the prime factors. Only with the 2, that case also it will terminate, remainder will be 0. If it has only 5 as a prime factor, that case also. Other than 2 and 5 comes, it will not terminate. It will have this type of non-terminating repeating decimal expansion. Okay, so, and we have to get the decimal expansion, we have to get the quotient after dividing this number with 125, what will be the decimal form of that answer. Okay, for that we learned that, see, this is a given number 125. You can do you can shift the decimal point accordingly. That depends on the denominator. If you can write as a power of 10, that is 10 or 10 square or 10 cube. Okay, see children, if 3 divided by 100, 0.03. Without dividing, you can write down the answer. So our aim is to convert or make the denominator a power of 10. Okay, so nearest power of 10. That 100 is definitely, but the next is 10 cube, that is 1000. Okay, so in order to make this to 125,000, which number you have to multiply? With 8. Okay, that is 125 into 8, 40. 4 carries 16. 16 plus 4, 22 carries 1 into 8, 8 plus 2, that is 10. Okay, and we know the equivalent fraction idea. Okay, if you multiply this given fraction with the 8, okay, that is, you will be getting an equivalent fraction of 12 by 125. That means you have to multiply the numerator also with 8. So what happens? That denominator now become 1000. That means a power of 10. Power of 10 means 10, 100, okay, 1000, likewise. Okay, that is 10, 10 raised to 1, 10 square, 10 cube. This is the way to get the decimal expansion easily. Okay, this is possible only when the denominator has the prime factor either 2 or 5 alone or both 2 and 5. If it has other than any prime factor, we can't write. Okay, you cannot make an equivalent fraction in this manner. Okay, so when you multiply 24, okay, 2 carries, that is 5 to 8 into 1, 8 plus 2, 10, 104 divided by 1000. Now without doing the long division, you can get the answer, decimal number for this. That means shift the decimal point from the right to left to 3 decimal places. Why? Because 3 zeros. So the answer is 0.104. 0.104. See the option? 0.104. Here 1.04, that is wrong. This also wrong. This also wrong. So the correct option is the first option. This is very important. Okay, so in order to get the decimal form, the decimal expansion which it terminates, okay, you have to convert the denominator as a power of 10 by multiplying with a suitable number. The same number you have to multiply with the numerator so that you can easily get its decimal form or the decimal expansion. Okay, so this is all about the MCQ question from first lesson, and I have prepared 2 videos of MCQ questions of real numbers. Okay, so don't miss these 2 videos. Do practice. Okay, and I have selected the very important question, the probable questions, and I have covered almost questions from each topic from this first lesson. So don't miss these 2 videos and get practice, more practice, so that you can easily get the question at the shortest time. Okay, so thank you children, thank you for watching and supporting my channel. May God bless you and all the very best for the examination.